Hi friends, now it is time to see the various types of machine learning algorithms available. So mainly there are three types of algorithms we have for machine learning or making our machine learn. The first one is called the supervised learning, where our data contains both input as well as the output. So we have a data set where we have input and its corresponding output, and these two together are given to the machine, and the machine somehow should find the correlation between input and output and create a model. And this model, when given with a new input, should provide us an appropriate output. So this type of learning, where the data contains both input as well as output, is called the supervised learning. So there's another one where only inputs are available, no output is available, and these inputs are used, and from the input the features are extracted, and the inputs having common features are clustered together. So there is something like clustering we can do, or when we try to find the features, then usually the size of the features or the number of features is quite less than the data itself. So we can also claim that the size of the data can be reduced if we use the features instead of the data itself. So that's what we call the dimensionality reduction. So we have two types of unsupervised learning. One is the clustering technique, other one is the dimensionality reduction. Yes, we have one more type of learning, which is the reinforcement learning, where we don't have any inputs available, outputs available, but yes, we have rules to play the game, or rules of the system we have, and using these rules of the system, the inputs are generated and outputs are generated, and then the generated output for any given input, is it useful or not useful, that's tried to identify, and through that we have reward or punishment system. So here what happens is we have something like an environment upon which agent acts, and the action of the agent will affect the environment, and this effect of the environment creates either positive effect or negative effect. If it is positive effect, then the agent gets a reward. If it is a negative effect, then the agent gets a punishment, and the agent keeps this information, and in future tries to repeat all the actions that fetch positive response or that fetch the rewards, and tries to avoid the actions that gives negative rewards or the punishments. So this is what we call reinforcement learning. So just look these one by one. So coming with the supervised learning, so here the model learns from the labeled data. That means we have the data in the form of input output pairs, and these input output pairs are used together and used for learning. So this input output pairs of data are given to the machine, and machine is asked to create a link between input and output, try to understand the correlation between input and output, and once the correlation is identified, a model is ready, and this model can be used to predict what output we can get for any given input. So the best example is the one we had used in our school days while we were learning. So here our supervisor was our teacher, who was trying to teach us what ABCD is and all that. And there, if you remember, that we were shown the image of A, or A written on the board, and she used to show that and say this is called A. So show the structure on the board and say this is called A. So there is an input. Input is the vision. What is A looks like goes into our eyes, and she keeps telling that this is called A, so that the voice gets into our ears. So the input is the picture and output was the voice, and the picture through our eyes get to the brain and some neuron fires. So whenever the structure of A is seen, one component of the brain fires. Same way, whenever we hear the word A or the sound of A through the ears, some part of the brain fires. And when we are learning what A is, how A looks like, how A is pronounced, then one goes to our eyes, the structure, how it looks like, and one part of the brain triggers, and A, the pronunciation goes to our ears, and another part of the brain triggers. So this is happening together. See A, listen A, see A, listen A, see A, listen A is happening together, and in the brain 2 points are getting triggered simultaneously, and this simultaneous trigger again and again and again and again will tell the brain that these two have some relation among them, and because of that some connection is formed. So forming this connection between two neurons in the brain, one coming from the visual side and one coming from the auditory side, firing together, will make us learn that whenever we see that the voice of A, we imagine or as if we hear it, or whenever we hear the pronunciation of A, suddenly the picture of A comes before us. So this is what we call learning, and in this learning teacher plays a major role. Teacher here we can call a supervisor, and this type of learning is what we call supervised learning. So the examples for our supervised learning in our machine learning case is like house price predictions and all that. A big list of data is given depending on where the house is, what is size of the house, how many bedrooms are there, how many what type of kitchen is there, whether that particular thing has got a garage or not, and all that. So many different items are discussed about a house, and finally its price. So where it is located, how far it is from the highway, all details are listed together. So it's a very big list talking about a property of a house and then its price. So this big table we have, and we as a human cannot understand how they are correlated and all that. So what we can do is we can dump all this data onto the machine and say that the data we have about the house, the property of the house or features of the house, how they are correlated with the price of the house. If you can correlate, then next time when we are trying to purchase a house, we get all these features, where the house is located, what is size of the house, how many bedrooms are there, how many rooms are there, what type of garage we have and all that. If we dump all this information to our model, it should tell us what is the expected price for that particular house and all. So this type of activity is what we call regression. So there is another type of thing where we can classify whether it belongs to this category or that category. Like we do have a big list of emails with us, and we just say that this type of email is a spam, this type of email is not a spam and all that. All these are dumped to the machine and say you try to identify correlation between what makes an email spam and what makes an email not a spam, and then when a new email comes, you just automatically classify it whether it is spam or not. If it is spam, then just forward it to the spam the folder. If it is not spam, then get it to the inbox. So that is supervised learning. Now coming to the second type of learning, which is called unsupervised learning, where the model works with unlabeled data. That means there is no output, there is only input, and we have to find some hidden structures from there. So there's one activity what we can do is identify the hidden structures, and put all the objects having similar structures together, which we call clustering. So here you can see from this image that we can see so many different objects. So I don't know whether we should call them flowers or animals or whatever it is, but the moment you look at it, we can identify that there are different types of objects found. So let us say that yes, there are flowers. Okay. So flowers. So there are some flowers which are of yellow type. There are some flowers which are of whitish things. There are some flowers which are of reddish type. Looking at that, we can immediately say that all the flowers which are of yellow colors are of one property. All the flowers here share some other property. All the flowers here share some other property. All these blue color flowers share some other property. In terms of structure, shape, color, fragrance, many features are there. So looking at the features, we can combine all the objects together into one cluster which share these features in common. So we don't have to understand what each object is, what they are called and all that. We don't need any name for them, just we need an input. That image is an input here, and looking at that we can just say that there are some 3-4 types of flowers available here. One is blue flower, one is yellow flower, one is this color flower, one is red flower and all that. So there is one more cluster here, one 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 cluster here. Then you can say that this cluster are similar, this cluster are similar, or this cluster may be similar and all that. So we are talking about in abstract sense. So we don't have to name them, but just looking at the data, we can just identify the hidden structures or some patterns from that, and then cluster them into different categories, different classes and all that. That is one type of unsupervised learning, because here nobody is there to help us. There is no output given here is what these flowers are called and all that. We are not interested in knowing names of the flowers. What we are interested in, features of the flowers, and looking at the features of the flowers, we can classify them into different groups. Same way you can think of other types of objects like animals. You can see there are different types of animals. So many animals are available here, but if you look closely, then we can find that there are some animals which share some common features, and these are one type of animals, these are another type of animal, these are one other type of animals, and we have deers here, we have elephants here, and so on. We can just cluster them into different classes, and that is what is an unsupervised learning. So how do we use the unsupervised learning for our machine learning problems? So we can segment the customers into different classes in the marketing problems, or we can segment the text data into different topics and all that. So we don't have to name them give them any particular name for that, but yes, looking at the features, properties, we can separate them. So that is unsupervised learning. The third case is the reinforcement learning, where an agent learns by interacting with an environment and receiving rewards or penalties. Yeah. Yes, definitely you should remember this. This is when you started learning how to run a bike. So when you are trying to ride a bicycle or a bike, so you didn't do it perfectly on the first instant itself. You did do it perfectly on the first day itself, or even first week. It took a lot of time to understand how to ride it. So to ride this, what are essential requirements are? Number one, keep moving. Unless until you don't keep moving, we cannot ride the bike. If we stop moving, we fall down. Second thing is maintaining balance of the handle. So maintaining balance of the handle means if we are tilting towards one side, the handle should be rotated such that automatically opposite tilt is created through the handle. So we should understand that if we are following this side, then handle should be turned to this side, and how much turning is to be done, and all these things have to be made sure while pedaling. If you stop pedaling, the motion will stop, then we fall down and all that. So many things we had to learn, but that cannot be taught by anyone, that cannot be learned by reading books and all that. It has to be personally experienced. And what is this experience is, you just get onto the bike and then start working on it. So first time you don't understand anything, what maintaining the speed is, what maintaining the balance is and all that. You don't understand anything. Keep falling, keep falling, keep falling, again and again and again. We keep repeating that. Whenever we fall, we realize that we made a mistake, we had an injury, penalty, and for some reason we could move further for some distance without falling. So that gives some happiness, and then we start introspecting ourselves, why we could move so long without falling. Then that way we just try to visualize what happened there, what actions I did, so that I could move till that point without falling. And if I can repeat those actions again, then will I stretch my movement for a longer distance. So this is how we went on doing, and anytime we made a mistake, we fell down, so next time we try to avoid making that mistake. So this feedback system, which is giving us reward or penalty, will make us learn. So that is how we learned riding the bicycle, that's how we learned swimming, that's how we learn to play any game, chess or anything. So we have to play, we have to ride, we have to swim, only then we can do it. It's not possible just by reading how to and all that. It has to be experienced personally, and that is what we call reinforcement learning. In our machine learning language, this reinforcement learning can be used to make the robots walk on their own. So we train the robots to walk on their own, then this the same way as we were making a human or a child to ride a bike, we try to teach a robot how to walk. So it has to use something like reinforcement learning, has to make mistakes, has to learn from mistakes, has to do some correct things, learn from correct things. So whenever it does correct things, gets a reward. Whenever it does mistake, gets a penalty. So try to get more and more rewards, try to get less and less penalties. That's what reinforcement learning is. So that's about the three major types of machine learning algorithms. One, supervised learning, where input, output both are there in the data, and the machine is asked to correlate between input and output and create a model. Second one, the unsupervised learning, where only input is given, there is no output. So from the input, some common features have to be identified and clustered into various classes and all that. And the third one is reinforcement learning, where neither input is there nor output is there. The agent is allowed to take some action, and from the action, environment gets disturbed in positive way, then rewards, in negative way, then punishment, and the agent should somehow learn to increase the number of rewards, reduce the number of penalties with time. So we say with time it is learning, it's becoming more and more expert and all that, and that is reinforcement learning. So that's it for now. Thank you.